we balance, keep in mind, what if you do this wrong? It doesn't matter, because even if your balanced equation is wrong, if you do the next part correctly with your wrong balanced equation, you can still get credit. Okay? So if you didn't do the balanced equation right, like, don't stress out. There's, like, you can still get some points. Okay? So, what do we need to balance here?
Put a 2 with CO and then a 3 carbon.
Yeah, I would, you guys, just so you know, like, I have carbon in multiple spots over here, which that's always like the last place I balance, okay? Because I know I'm going to have to balance my oxygens, and my oxygen is attached to a carbon, so before I like deal with carbon, I'm going to fix oxygen. So I'm going to put a 2 here, and then how many carbons do I need total? 3, okay? All right, so that's the balanced equation. Yes?
So, does carbon not need, like, it's not diatomic or whatever?
Nope, carbon's not diatomic. Did Kernosh tell you about Hunkelbrief? Right?
So those don't need it, right?
Oh, okay. So just so you know, I actually do the rule of 7, like, which for me is easier, but people like Hunkelbrief. My rule of 7, and I'm going to air draw here, so follow me, and I should get on camera for people who are absent. My rule of 7 is start with number 7, which is nitrogen, right? Follow me here. Nitrogen, oxygen, fluorine, chlorine, bromine, iodine. Do you see that it makes a 7?
Yeah.
Nitrogen, hold on, follow me. Start with 7, make a 7, hydrogen is the 7th one. That's how I've always remembered it, the rule of 7. Start with 7, make a 7, hydrogen's the 7th one. So I go nitrogen, oxygen, fluorine, chlorine, bromine, iodine. That's 6 out of 7. Hydrogen's the 7th one. That's how I remember it. If you like Hunkelbrief, that's hydrogen, oxygen, nitrogen, chlorine, bromine, iodine, fluorine. Like, use whatever works for you. The idea is just to know who they are, okay? But carbon is not one of them, okay? So, all right. What do we do now?
Figure out the ratio.
We're going to need the ratio, yes. To figure out percent yield, what information do we have? What's this?
That.
That's the mass of a reactant, right? What's this?
Mass of a product.
Mass of a product. What type? Is it actual yield or theoretical yield?
Theoretical.
It's actual yield.
Like,
Where do we get theoretical yield from?
math.
Math. A fence. You need to find your theoretical yield. Make a fence. It's going to be a biggie. What? You can do it. You just all look like you're dying right now.
Yeah.
Amber got here late. She's the only happy one. She's like, thank God. It's all good. I've slowly, like, just wrecked them this class period. It's okay. How we doing back there, Sierra? Yeah, I know. Do you see why I needed you to get it started? Yeah. And the more iron that, like, gets in the filter, the slower it filters.
Yeah, the first couple times I poured stuff in there, it was like that.
Uh-huh.
And now it's like going.
I will spend all day doing that. Like, I just wanted you to get it started because you had more time on your hands to, like, look at it every couple minutes. So, yeah. All right, are you making a fence?
Yeah.
You guys know how to do this. Come on, this is straight, wait, hold on. This is straight up stoichiometry, with the exception of kilograms.
What are you like converting to on the
Okay. Well, what are you being asked to, like, so this is where, okay, you're given this, right? You're given this, which is actual yield, right? We need to find the theoretical yield. So you are finding the theoretical yield of this. Because to do percent yield, you need to do actual divided by theoretical, right? But we don't know our theoretical. So you are going, basically, kilograms of sand, which is SiO2, to kilograms of SiC. It's okay. You guys, I promise you all did this last year, and I know you probably did really well. This is, with the exception of the fact that this says kilograms, this is actually a straightforward stoichiometry problem. It's a grams to grams, basically. What? You still are. It's just that it's starting, you guys, you're still good at it. It's just starting to look harder because the problems are not broken down as easily.
If it's kilograms, does that mean you have to convert them all in mass?
No, I would just convert kilograms to grams. What's the relationship? So, like, if I did this, I'll show you. I'll get you started here. If I did this, like I start with that, right? I would just get rid of kilograms right now and go kilograms to grams. What's the relationship between kilograms and grams? 1,000. Where did the numbers go? 1,000 grams for every 1 kilogram. And then I would just, from there, do my typical grams to molar mass to blah, 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 blah. I am recording this, so just so you know, like, really seriously, whether you're here or not, I would go back and watch this video for how to do this, okay? Especially, like, that bell's gonna ring. I'm gonna start moving along with you here, okay? So that for people not in my homeroom, we have some time. So yeah, what do we do here? Molar mass of SiO2, which, you know, keep in mind, we're still on SiO2. So we want grams of SiO2 down here. What goes up here? What goes up here? 1 mole of SiO2. Okay, just real quick. O2 is 32 plus, what's silicon? 28.09. So 60.09. Get out your calculators because we're going to have to move here. Where do we go next? Now we have moles of SiO2. What do we do? Put them on the bottom. Now that we have moles, this is where we can make our switch. Remember, the whole reason we get this to moles is because how are these two substances linked? By the mole ratio. So the way we can switch substances is by using the mole ratio. What is the relationship between moles of SiO2 and moles of SiC? 1 to 1. And then what do we need to know? The molar mass of SiC, which is 28.09 plus 12.01, 40.10. Does that sound right? Mm-hmm. Great. 40.10 grams of SiC. Honestly, I'd get my answer in grams and then convert to kilograms. Who has a calculator out? Come on, do the math for me quick, because that bell's going to ring in 2 minutes, and I want to get through this.
I think it's 57%.
You better be showing work that somebody can follow, because you will not get credit on your test.
Wait, is it? I don't know. I did this a couple minutes ago.
I know, I'm just telling you, like, my concern for
Okay.
you is for a free response question. If your work is not clear and logical, you will not get credit. Okay? So,
Come on.
and I don't want to know the percent yield. I want to know the answer to this fence. You guys, even when that bell rings, just give me an extra minute, like, so that we can get this, okay? What's the answer to this fence? I think it's like 66,000, isn't it?
733, yeah.
66,733 grams. But what do I want it in? Kilograms. So I'm going to do, how many sig digs do I get? How many sig digs do I get?
How many do you want or do you get?
How many do I get? 4. Don't move. I get 4. Yes, thank you. Okay, this is my theoretical yield. What do I do to find percent yield? Actual divided by theoretical. They gave us the actual. 51.4 divided by 66.73 times 100 equals. Is Jonah right? Is it?
Definitely not.
Oh.
I think I forgot about the kilogram part.
So get an answer. 77.02. So we'll go 77.0%. Done. Okay. Is that doable?
Yes.
But you gotta, like, be able to think through the problem.